Good morning and welcome to all of you. I hope you had a great weekend and you were able to enjoy the beautiful sunshine outside. So today, what we're going to do is we are going to um, take on lesson one, and we will talk about in lesson one quadrilaterals and their characteristics. So let's take a look at some of these first because um, see what can we do before we look at their characteristics. What is a quadrilateral? Um, so quad, the word quad means four, four. So the word quad means means four. Okay. So the next part, quad, and this part here, lateral. Lateral, the word lateral means sides. Okay, and then they just put the connector in there. So quad means four, lateral means side. So if you put the pieces together, the word together, quadrilateral literally means four sides. Four sides. So what are we going to talk about today? So anything that has a four-sided figure. Four-sided figure. There are quite a bit of four-sided figures that we know of. Like we know square is a four-sided figure. Okay, we know that from when we were little. We know about rectangle. That's a four-sided figure. But we're gonna also talk about other shapes that are four-sided figures that are and their characteristics. Now, let's take a look at the word characteristics. Each one of us have our own characteristic, and that's how we can identify each other. So when we say characteristics, what are the things that can describe the quadrilateral? Because not all quadrilateral are the same in terms of characteristics. The only thing that they have in common is that they all have four sides. But other than that, there are some, other characteristics that are true for some, not true for the other. Okay, so let's go ahead and look at this one. So quadrilateral are four-sided enclosed shapes. Okay, so we already talked about four-sided, and I like the way they had this enclosed shape because it is a four-sided, but then it has to close close each other, right? So like I can't just say, hey, this is a four-side, but it's not a closed shape. Okay, so it has to be a closed shape. Certain quadrilaterals have special names. Okay, we're going to talk about some of those special names and special characteristics. So each type of quadrilateral has different properties. Properties means also characteristics. Okay, so another word of saying characteristics. So we're going to take a look at their sides. Okay, we're going to take a look at in terms of sides. Okay, are there any congruency? Are there anything equal? So any sides equal. So that's basically what we're going to talk about. Like, what are any sides equal to this quadrilateral? Okay, so that's what it means. And then we can the word congruency, but it's just basically it's exactly the same measure. Then the next thing that we're going to take a look at in terms of characteristics of quadrilateral is that any sides are parallel. Okay, what does it mean by parallel? Like two sides that are parallel. So we're comparing some sides. Two sides parallel. That means do they go in the same direction? Okay, so this means, you know, this in this line, they're going in the same direction. These two are parallel. And then um, perpendicular. What does perpendicular mean? Perpendicular means it creates a 90-degree angle. Okay, it creates a 90-degree angle, and then pertaining to the other sides, and then whatever the other sides are. Some are not parallel, some are not perpendicular. Okay, and then we will talk about that too, and other sides. So next one is length of diagonal. Okay, so what is a diagonal? A diagonal is a line that stretches from one corner of the quadrilateral to the other corner. So an example of a diagonal, okay, diagonal is, I'll do it here. Okay, so this is like some kind of a four-sided figure. A diagonal is from one corner, but instead of going that corner, we're going to go to that corner. So this is the diagonal right there. Okay, so some diagonals are, I won't mention that right now because we're going to uncover it later. I don't want to get too ahead of myself. And then angles formed at intersection of diagonal. So when we look at the diagonal, okay, there are going to be two diagonals. So we're going to look at the angles at the intersection of diagonals. So we're going to look at the angles created or formed at the intersection of diagonals. So let's say we have this shape, okay, this quadrilateral right there. And if I draw a diagonal this way and then I draw a diagonal this way, we're going to look at the intersection. What kind of angle are they forming here? And then what the angle forms here and then there. Okay, so that's another characteristic or another property that we're going to take a look at. Not all quadrilaterals are the same. So certain quadrilaterals have certain characteristics. Bisection of diagonals. Okay, bisect. Bisect, bi means to, sect means to cut it. So bisecting diagonals. Okay, so again, looking at the quadrilateral, and then when we look at the diagonals, something about bisection. Bisection, it means two parts of the diagonal. And we're going to take a look at some of those properties. And then next, size of interior angles. That means the sum of all four interior angles is equals to 360. So they already mentioned that, regardless of the type of quadrilateral. So this is something that's true for all quadrilateral, for all four-sided figure. The sum of the four angles is equal to 360. So it's always true. Okay, so let's take a look at that one for a second. And why is that true? Why is that true? Okay, so this is from what we did before, from last time. Okay, when we look at the triangle, let's look at the triangle. And you know this already. We said the sum of angles in triangle is 180 degrees. sum of the triangle is 180 degrees. That's for a three-sided figure. So three sides. Now, what about the four-sided figure? Four-sided figure. Okay, I'll just draw a four-sided figure right there. Okay. It may or may look like that. It kind of looks like a square, but this happens for all quadrilateral. Now, for four-sided figure, means for quadrilateral, how can we show that this is going to be, the sum is 360 degrees? How can we show that? Okay, well, the only way we can show that is if we pretend we can cut this in two equal parts. Okay, so if we cut it into two equal parts, okay, so into triangles, basically into triangles, then we have these angles, these three angles, it's going to add up to 180. And then these angles are going to add up to another 180. So if we add them all together, okay, if we add these two, and then this, it's going to add up to 360. Okay, well, that's probably true because if this is a square, it makes sense because this is 90, 90, 90, 90, right? You're probably thinking, oh, that makes sense because that's a square, and a square has 90 degrees on each corner. So that makes sense, right? If we add them all up, it's going to add up to 360. But what about the other shape? What about the other shape? What other quadrilateral? So I'll just make up any quadrilateral here. Okay, so this is a quadrilateral. Okay, it's not one of those typical things that we know of. So it's a four-sided shape. Okay, so, oh, by the way, you can, you don't have to write this down, but I just want to show you that the sum of all the angles of this quadrilateral is 360 degrees. So you don't have to write this down. If you want, if you're already writing it down, then that's okay too. So what I'm going to do with this one is I'm going to cut it into triangles, okay? Because what do we know about triangles? Triangles, it adds up to 180. So if I cut this into just two triangles right there, two triangles, then I'm gonna have I'm gonna have a this angle, this angle, this angle. So this piece, if I add these three, it's gonna add up to 180. And then if I add these three, that's another 180. So if I get rid of all these, what's going to happen? This whole thing plus this plus this plus this is going to be 360 because these three angles in here is going to be 180. These three angles here are going to be 180. So together, 180 and 180 is going to be 360. So that's just to show us that it doesn't matter. So this is a characteristic that is true for every quadrilateral. So this is true for all quadrilateral. Okay, so we talked about some of those things, and then the last bit in here, consecutive interior angle. Consecutive, let's break it down for a second here. The word consecutive means one after the other. So consecutive means, this means one after another. Okay, consecutive, so one after the other. Now, interior. Interior means inside, inside, and then angle. So the angles inside that are one after the other are called consecutive angles. So some of these stuff here that we are looking um, are just some vocabularies. Okay, so when we look at these things here, we can identify them right away. Okay, so we are gonna look at specific quadrilateral. Okay, special quadrilateral because they have a specific name, and we're gonna look at their characteristics. Okay, so we can identify them. So here we go. The very first one that we're going to take a look at is called parallelogram. Parallelogram. So these are all parallelogram. So what does that mean? Um, side lengths. Side lengths. What do we know about their side lengths? Well, in terms of parallelogram, their side lengths. So if I can measure this side and I measure this side, these two sides are equal to each other. Okay, and then if I measure this side and if I measure that side, they're equal to each other. Now if I measure these two, they're not equal to each other. So in terms of parallelogram, how can we identify which sides are congruent, which ones are equal to each other? So what we can do is we can say, how do we describe this and this? So we can't just say, you know, two sides are equal and then the other two sides are equal. No, we have to be more specific. So we can say, in terms of side lengths, opposite sides are equal. So we can say opposite sides are equal. Opposite sides are equal. No. Okay, so we can't just say, hey, two sides are equal and the other two sides are equal. We have to be specific. The word opposite means not right beside it, but right across from it. Okay, so this side and this side are equal to each other. Okay, and then this side and this side are equal to each other. So what we could do, here's another thing that we could do, is we can name the sides. Okay, just like, so if we call this A, B, C, and D. So this one here is going to be a little bit different way of describing the sides. We can say AC. Okay, so this side is called side AC. Okay, so AC, and then I want to make sure that I'm talking about this side, so, and I put a bar on top. Bar means it shows us it's a line segment. Okay, there's quite a bit of stuff in geometry that are, a short way of writing things down. So from this corner to this corner, that's a line segment. That's why we put a line there. That AC is equal to side BD. BD, like that. Okay. Oh, what did I say? BD. BD. That's meant BD. So from AC to BD, those two are equal. Well, what else are equal to each other? We said opposite sides are equal. So what are other opposite sides? I can say AB, 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 line segment AB is equal to who is it equal to? CD. Is equal to CD. And then I put a bar on top, a line on top, indicating that these are line segments, the lines. Okay, so that's that. Um, uh, in this particular lesson, I forgot to mention that it's a lot of talking. There's not much, not much calculation at this particular stage of it. But what we're trying to do is we're just writing down and figuring out what are the characteristics of it. Okay, so you're probably thinking, oh, is this really math? Really? But right now, not much calculation. Which is kind of nice because we've been doing a lot of calculation lately. Okay. So let's move on to the next one. Parallel sides. Okay, what does it mean, parallel again? Parallel means going in the same direction, just like, the railroad tracks are going in the same direction, right? Uh, One thing is not going on, parallel is going this way and then this way, right? No matter what, if we continue on, it's not going to intersect at all. It's not going to intersect. So that's what it means by parallel. So now, are there any sides that are parallel? Parallel sides. Okay, well, let's see. Parallel sides. Parallel side, let's see here. I'm actually going to use this quadrilateral here to show parallel. And you're probably seeing these marks on these things, okay? Uh, um, this hash mark right here, we've used that in trigonometry. It means the same length. So this is the same length as this. Opposite sides are equal to each other, and then these two opposite sides are equal to each other. I'm using the right terminology here. So opposite sides are equal to each other. That's why there's one line here and then one line there. So that means these two are equal or congruent. And then can you see that there's two lines in here and then there's two lines there? That means these two are equal to each other. Now, what about these two? This one we haven't quite seen this. It looks like an arrow, right? It looks like an arrow. It looks like kind of shows some kind of a direction. What's going on in here? Now, because it kind of looks like in the same direction, it's just like that shows us the parallel characteristics of this parallelogram. Can you see this one here? One arrow going this way, that means it's going in this direction. And then there's another one right here going in the same direction. So these two are going in the same directions. That means they're going to be parallel to each other. So I'm going to go here. I'm going to use the same labels in the vertices. Vertices, we said, are the corner points. So I'm just going to use the vertices here. Corner points. Like that. So what can we say? Parallel sides, any parallel sides. How do we show that this side is parallel to this side? Okay, well, how can we describe them, these two sides? Well, they're opposites of each other. They're opposite of each other. So we can say opposite, and then this. Can you see there's two arrow this way, and then there's two arrow this way? So that means these two, okay, you can't probably see my finger, but they're going in the same direction, right? They're parallel to each other. So in this case, we can say opposite Opposite means right across from each other. Opposite sides are parallel. Okay, opposite sides are parallel. Now, how can we, you know, how can we say that? Or, I mean, we can say that like that, but is there another way of describing that they're parallel to each other, right? Um, Back in the olden days, like there's, these mathematicians, these people who are um, learning and describing math. They don't have a lot of paper. They don't have paper. They don't have a lot of pencil. They don't have a lot of pen. So what they need to do is what they need to express their ideas in a very, very short way. So that's how they have this shortcuts instead of writing all these things. What's the shortcut to saying that? Okay, so here it is. We can say, put this right there. This is for that part. We can say that um, A AC, okay, again, line segment AC is parallel. Okay, this is a symbol for parallel. Look at that, parallel. Looks like two lines that are parallel. AC, line segment AC is parallel to what? To BD, BD, like that. Okay, so we can say AC or CA, it doesn't matter, right? But we'll go AC is parallel to BD or DB. Okay, well, which other ones are parallel? The other parallel are AB, line segment AB, that's why we put a line above it, okay, is parallel, so this is a symbol for parallel to CD. So those mathematicians, instead of writing this sign opposite sides are parallel, they're just write that, and then everybody knows what they're talking about. Okay, so that's that piece. That's that piece for that one. Okay, so let's take a look at this one. Perpendicular. Okay, well, what's a perpendicular again? Perpendicular means two sides that are creating a 90-degree angle. Any sides that are perpendicular. So we can look at this one in this particular case, because this is a parallelogram. This perpendicular, or any sides are perpendicular. In this particular case, no, none. Okay, no perpendicular sides. Okay, so it means creating a 90-degree angle. So if you take a look at this part in here, AB, and then this part in here, AC, they're not 90 degrees. Okay, so they're not perpendicular. What about CD? And this is not 90 degrees as well. So it's kind of tilted to the side. So it's not 90 degrees. So none. No perpendicular sides in a parallelogram. So let's take a look. Now we're going to get into diagonals. Okay, what are the diagonals again? Diagonals means from one vertices to not the next vertices, not the consecutive one, but the opposite to it. So from here to here, that's a diagonal. So the diagonal is from, okay, I'm going to label this one again. This is A, B, C, and D. So the diagonal would be the line from C to B. Okay, so this is diagonal. That's a line segment BC, or we can say CD. And here's the other diagonal from AD or DA. That's also a diagonal. So the question is, are diagonals congruent? So we have two diagonals in here, this AD and CB. Are they equal to each other? Now, you could probably see that because this is kind of tilted to one side, CB, diagonal CB is longer than the other, longer. So I'm going to show us that it is longer. So AC, let's see if I can, this is bright enough for us. So if I go AD first, AD, I don't know if you can see that, but it's from 1 to 2.5. So from A to D, that's 2.5. Okay. And then from C to B, that's, and then this is like, can't see. It's about 4. So this one here is 2.5, and then this one is about 4. So they're not congruent. They're not equal to each other. So are diagonals congruent? No, they're not. Diagonals are not congruent. They're not equal to each other. They're not congruent. Forgot the end. Like that. Okay. Okay, so next one. What's the other information that we have? Diagonals are perpendicular. Okay. Diagonals again. We're just going to keep looking at the diagonals. Are diagonals perpendicular? Are diagonals perpendicular? Okay, so the diagonals CB and AC, are they perpendicular? So the word perpendicular means they create a 90-degree angle. 90-degree angle. So in that particular case, in this particular case, if we measure this angle and we measure this angle, they're actually not 90 degrees. They're not 90 degrees. Okay, let me see if I can find oh, here's my protractor. That's what I'm looking for. Here's my protractor. So if I go like this, measuring the angle, so here, I'll bring it down a bit. If you were in our class in grade 11, we looked at how to read a protractor. So we said that the line has to start at 0, and then this, or the turning to create the angle, that has to be right there, the center. So this particular case, so this is the initial arm of the diagonal. That's for this diagonal here. That's my initial arm. And then I'm going to turn this way, and then this is my final arm. So right there. And then my initial arm is 0, and then my final arm goes here. This is 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. So certainly from here to here is more than 90 degrees. More than 90 degrees. It's in fact 110. Um, Another way that you can show that without using a protractor is this. Okay, so if this is my line, and if I'm gonna create a 90 degrees, 90 degrees should be this way, right? So this is 90 degrees. It has to be like an L shape, but in this one here, it's like a little bit more, as you can see. So it's not perpendicular. Okay, so diagonals are not perpendicular of each other. Okay, so they don't make 90 degrees with each other. Okay, so as you can see here, this is more than 90 degrees, and then if we measure this part here, it's actually less than 90 degrees, less than 90 degrees. Okay, so these part, are the diagonals congruent? No, because the fact that it's tilted to one side, it makes this diagonal longer, and then diagonals are not perpendicular to each other. Okay, next one. Do diagonals bisect each other? That means, do the diagonals bisect each other? Do the diagonals cut each other in half into two equal parts? Two equal parts, bisecting is two equal parts. So when you look at this part here, okay, so here's your diagonal AD, and then here's your diagonal BC or CB. If this is my knife would be somewhere here in the diagonal CB. What happened is it will cut AD into two equal parts. Sorry, you can't see that. It cuts it into two equal parts. So this part, and then as you can see this, from here to here is equal to from there to there, from the center. So they cut each other in half. And you can see this hashtag in here, the line indicating that from this corner A, from vertices A to where diagonals intersect. Okay, this is the intersection of two diagonals where they meet. From here, vertices A to the intersection of the diagonals, and then from D to the intersection of diagonals, they are equal to each other. Now, what about this one? If AD is my knife and I put it down like that, what's going to happen? It bisects. Bisect means cutting into two equal parts. The line segment, this diagonal BC. And then you can probably see that two line segments there, and then two hash marks there, hash marks. So from C to this point of intersection, and then from this point of intersection to B, they're equal to each other. So it means the diagonals bisect each other. Okay, so diagonals do bisect each other. It means they cut each other in equal parts. Okay, now we're on the last bit in here. It says angle sizes. Are there any angles that are equal? Okay, are there any angles that are equal? This is really how do we know which angles are equal? So if we take a look at this first parallelogram in here, basically these are the same parallelogram. It's just that they focus on different parts of it. So now this first one focuses on angles. So what does that mean? Angle A here, and angle D are equal to each other. Angle A and angle D are equal to each other. So how can we say that these two are equal to each other? How can we make a general thing statement? And then we can also see here, there's hashtag in there, or not hashtag, hash mark, and hash mark there. Angle C and angle B, these two are equal to each other. So how can we say that? We can say that opposite angles are equal to each other. We can say opposite angles are equal. Okay, they're opposite of each other. So angle A and angle D are equal. Angle C and angle B are equal. Okay. So in this particular case, we've looked at the general characteristic of a parallelogram. General characteristic of a parallelogram. Now, parallelogram actually has very specific, there's, in terms of a family of parallelogram, there's different members in that family. So has several shapes that are also considered special parallelograms. They're special, but they have their own names. So here's the special parallelogram: a rhombus, a rectangle, and a square. And then we will look at those special parallelograms. Okay. So if there's anything in here that you are any questions, just make sure you let me know. Oh, okay. Another thing that before I move on to the next one, I just didn't want to forget about it. We can say that angle sizes are equal to each other. So we can say angle A is equal to angle D. Angle A is equals to angle D. Or, okay, what's other equal to? Angle C is equals to angle B. That's for this one. Okay, so take a look at that one. We're going to move on to the next one, special parallelograms. Okay, so we are probably just going to, this one is a special parallelogram. So we looked at a parallelogram and their characteristics, but with this one here, the next little bit is focusing on special parallelogram. And because they're so special, they have a name on its own. Okay, so the very first one is a rhombus. This one's probably going to be a little bit shorter, a little bit faster to talk about because we've already seen some of the characteristics in a parallelogram. So we can say, let's go ahead. Side lengths. So any side lengths that are congruent. Okay, as you can see here, can you see here the sides? I'll just name them again. So A, B, C, D, and I'm going to actually put an E in the middle. E in the middle, okay, so that it's probably easier to describe them as we go on. So in this particular case, any side length congruent. Well, the special thing about rhombus is that, can you see here, the sides are all equal. And this is really interesting. Opposite sides are equal, that's true, but these two are also equal. Consecutive sides are also equal. So we can say all sides are equal. Okay, so all sides are equal. So we can say AB, BD, CD, and AC are all equal. Okay. So AB is equals to BD. Okay, AB, BD equal to CD or DC, doesn't matter, is equal to CA for AC. They're all equal to each other. Now, let's take a look at the parallel sides. Any sides parallel? Yeah, because this is a parallelogram, the opposite sides are parallel. Opposite sides are parallel. So that means opposite side AC is parallel to BD or DB, and AC and BD, and then AB is parallel to CD. So AB is right here, parallel to that one. Now they didn't show it. They didn't show it on here, but to actually show it onto that, we can go like this. So to show that they're going in the same direction. So that means opposites, yeah, opposite sides are parallel. Okay. Next one. Perpendicular sides. Any sides that are perpendicular to each other. So now if you take a look at that one, nope, because it's tilted, it's onto the side, it's not. So this is not going to be 90 degrees. So if this is CD, 90 degrees should be like this, but it's tilted to the side, so that means it's not 90 degrees there. So perpendicular sides, no perpendicular sides. And are diagonals congruent? Are diagonals congruent? Okay, which ones are diagonals again? So from one vertex to the opposite vertex right here, right there. Now again, let's see if we can just rationalize this or think about it. If this is a parallelogram and it's turned to the side, now what happens is that this diagonal gets longer, right? This diagonal gets longer, so, and then this one has to get shorter. So that means diagonals congruent? No, diagonals are not congruent. Diagonals are not congruent. Okay, what else? Are diagonals perpendicular? This is really interesting, because when you look at this part in here, I don't know if you could really see it this way, but when you look at this diagonal CB and AD, they form at this intersection right there a 90-degree angle, and you can see there's a little square there that indicates a 90-degree angle. So are the diagonals perpendicular? Yep, diagonals are perpendicular. Okay, so um, let's see here. So if I measure this angle to that angle, so you can see this is like an actual L shape, L shape. And then I go like that. Yep. So this is my initial arm, and then this is my final arm. So it's 90 degrees. Okay. So they are perpendicular at diagonals are perpendicular to each other. Okay. Do diagonals bisect each other? Yeah, yes, they do. So that means this diagonal CB bisect line the diagonal AD, and then vice versa. This diagonal AD bisects the diagonal CB. And then you can see that there's a line here. Those are hash mark 2 in here. So that means from A to E is equal to D to E. And then you see the two lines indicate their two sides are equal. And then when you look at this side, CE, CE. So from C to the center, right there, the point of intersection, and you see there's three hash mark. I keep saying hashtag hash mark. And then from E to B, there's three hash marks right there. So CE and EB are equal to each other. So yes, diagonals bisect each other. Bisect each other. Okay. And then lastly, angle sizes. Are there any angles that are equal to each other? Okay, so angles that are equal to each other. Well, we can also say um, angle opposite angles are equal to each other. Okay, so let me bring it down. Angle A is going to be equal to angle D. Okay, and they're opposite angles to each other. And then angle C is equal to angle B. And how are they situated? They're opposites to each other. So we can say opposite angles opposite angles are equal to each other. Okay, so we can say angle A is equal to angle D, right? And then angle C is equal to angle B. Angle C and angle B are equal to each other. Okay, so I think this is a good place to stop here. Um, Tomorrow, okay, right now we're not quite ready for any assignments or any practice stuff, but tomorrow we're gonna continue on with this. We should be a little bit faster tomorrow because we've already introduced stuff. If you want to read on, just kind of read ahead, and if you have nothing else to work on, just kind of read ahead, and then we will talk about them tomorrow. Okay, so so for today, if you have any questions with whatever stuff that we've talked about today in terms of geometry, or even if you have questions about old materials that we talked about in trigonometry, just send me an email, and then I will get back to you as soon as I can. So what I'm going to do is I'm just going to stop right here, and then we'll continue on tomorrow. So uh, I just want to say thank you for watching. Thank you for participating at our lesson today. And then I'll talk to you tomorrow. And have a great day, everybody. Okay, bye for now.